You feel completely still right now, but you are actually spinning, orbiting, and constantly hurtling through the dark void of space. Earth rotates at over 1,000 kilometers an hour, while racing around the sun at nearly 100,000. And our entire solar system is moving even faster. We are orbiting the center of the Milky Way at a staggering 720,000 kilometers an hour, locked on to a direct, unavoidable trajectory with our galactic neighbor, Andromeda. The quiet night sky hides a violent momentum. We are currently strapped into the largest incoming cosmic impact our neighborhood will ever see. The Andromeda galaxy carries roughly 1 trillion stars. The Milky Way brings another 300 billion to the table. When numbers that large hurtle toward each other, total cosmic carnage feels inevitable. Yet, despite the immense gravity and mass of those colliding galaxies, the chance of any two individual stars physically crashing into one another is almost mathematically zero. To comprehend what happens when galaxies meet, we have to throw out everything we know about how things crash on Earth. Interstellar space is defined by its emptiness. On average, 47 trillion kilometers of vacuum separate any two individual stars. Picture shrinking Earth to the size of a single virus. At that scale, our solar system becomes a standard golf ball. Apply that exact scale to the Milky Way, and the galaxy stretches to cover the entire North American continent. Imagine firing one golf ball from Los Angeles and another from New York. The likelihood of them striking each other midair is practically non-existent. There won't be a wall of physical fire. Instead, two unimaginably massive, empty spaces will simply pass right through each other like ghosts. But physical impact isn't the real danger. Even passing quietly in the dark, foreign stars bring immense disruptive gravity. The first signs of trouble would trigger at the furthest edge of their territory, in an icy bubble of planetary debris known as the Oort cloud. NASA's Voyager 1 spacecraft travels 1 million miles a day, yet it'll take another 3 centuries to reach the inner edge of this perimeter. A passing star's gravity would scramble those ancient ice chunks, dislodging them and sending thousands of new, deadly comets hurtling inward toward the sun. An invading star system billions of miles away wouldn't need to touch us. Its invisible pull would turn our own planetary shield into a weapon against us. Closer to home, the delicate balance of our giant anchors would warp. Jupiter and Saturn would be dragged off their ancient, perfectly established orbits. Those shifting gas giants would send a shockwave of cascading gravity through the inner planets, slowly pulling Earth's circular path into a severe elliptical loop. The changing distance from the sun would violently rupture our climate, unleashing frozen winters, massive tectonic shifts, and kilometer-high tides. At peak gravitational stress, Earth is accelerated onto a hyperbolic trajectory, ejecting us from the solar system to drift forever as a frozen rogue planet. In the absolute worst-case scenario, our wandering planet crosses the path of an invading exoplanet, resulting in a direct, high-speed collision that completely vaporizes both massive bodies into violently swirling clouds of superheated gas. While the physical space between stars is overwhelmingly empty, gravity spans those gaps. One close pass is enough to unravel a solar system completely. Those destructive paths represent a tiny fraction of the probabilities. Because the void between stars is so immense, the overwhelming likelihood is that we thread the needle without a single encounter. On a macro scale, the Milky Way and Andromeda will repeatedly pass through one another, acting like cosmic pendulums that slowly lose momentum. Over billions of years, gravity acts as a gradual brake, stealing their momentum until the massive structures permanently bind. While the galaxies stretch and fold, our solar system will simply glide along for the ride, eventually settling into a quiet, stable orbit around a newly formed galactic center. Provided we maintain our distance from passing stars, this massive structural change happens in total silence, leaving our planetary neighborhood physically undisturbed. The distinct spiral shapes of both galaxies disappear, replaced by a single, complex arrangement of billions of stars. Astronomers already have a name for this merged luminous superstructure: Milkdromeda. Every constellation you know will be wiped away. In their place, the night sky will burn with a dense, packed panorama of overlapping star clusters and vibrant nebulae. This merger functions as a total structural renovation, proving the universe is resilient enough to survive its own most violent collisions.